All right. Looks like we're going to have Trig Lecture 418 through 421. We're going to be solving problems involving distance, rate, and time, where two objects are moving in either the same direction or in opposite directions, and the rates of speed and the time are not necessarily going to be equal. They might be, they might not be. But I'm going to try to illustrate the type of thinking we're going to use to solve these problems. It's not technically trigonometry, but it's, again, good tools to have in our toolbox for mathematical thinking. So here we go. Take a look at what we're dealing with. It's a little short word problem. Amanda drove due east. 2 hours later, Elisa drove due west. She's going 5 kilometers rather per hour slower than Amanda. And she travels for 3 hours, after which time they were 345 kilometers apart. Find Amanda's speed. Well, let's just break this thing down and take a look at it. Amanda drove due east. So here's due east. I'm going to say the distance is equal to the rate times the time, and I'm going to be changing these when I plug in the values that I know. I'm going to call this d sub a because we're talking about Amanda. This is just what the little a stands for. D sub a is equal to RT. Now let's read it again. Amanda drove due east. 2 hours later, Elisa drove due west. So we're going to just, and we've got distance is equal to rate times time. And this is d sub e for Elisa. She drove due west, and she's going 5 kilometers slower than Amanda. So if this is R, this is R minus 5. So I'm going to put that in there. Switch this over. Whoop. R minus 5 in parentheses times T. So 2 hours later, so the time is different also. If she left 2 hours after Amanda, then her time will be time minus 2 hours. So if Amanda drove for 10 hours, she drove for 8 hours, so forth and so on. So we've got an algebraic representation that we're working on here. 2 hours later, Elisa drove due west. She was going 5 kilometers slower than Amanda, so she's going 50, she's going 45. She went 10 hours, she's going 8, so forth and so on. After which time they were 345 kilometers apart. That's an important piece of information. After a certain amount of time, she drove for 3 hours. So this right here is 3. T minus 2 is 3. 2 hours later, Elisa drove due west going 5 kilometers per hour slower than Amanda for 3 hours. That's a good piece of information. This is 3 hours. That's 2 hours less than Amanda, so that would have to be 5 hours. So we're plugging in what we know based on what we're reading. R times 5, I'll call that 5R at some point, I would imagine. After which time they were 345 kilometers apart, and that's a good piece of information because after a certain amount of time, the distance that they travel is going to be 345 kilometers. That means if I add this distance that Amanda traveled to this distance that Eliza traveled, the sum will be 345. So that's what I'm going to do. I'm going to say this, Eliza's distance, or Elisa, or however we pronounce that, plus Amanda's distance, R5, I'm going to call it 5R, is going to equal 345 kilometers. Okay? And now what is it I'm looking for? I have an equation. I've got to figure out what it is I'm looking for. What is Amanda's speed? That's this R right here. The distance Amanda travels is R times 5. Okay? So here we go. I'm solving it for R. This is going to be 3R minus 15. I just distributed the 3 plus 5R is equal to 345. I'm going to combine these like terms, 3R plus 5R. oops, said I was going to combine them, and then I didn't combine them. 3r plus 5r is 8r, minus 15 is equal to 345. I'm going to add 15 to both sides. I add 15 here, it disappears, leaving me with just 8r. I add 15 here, I get 360, and divide both sides by 8. I'll try to do this in my head, but I'll check it with my calculator. That'll go 4, 5. And that's a rate, and our rate is measured in kilometers per hour, if I haven't made any mistakes, okay? So let's take a look. There's our answer. If I haven't made any mistakes, let me see, look at my key and see. 45 kilometers an hour, yay! So that's the type of thinking we're going to be doing. If they're moving apart from each other and they give us, you know, how far apart they were, we just add the two distances together that are in variable form. Make sure we plug in everything we know into the two distance formulas and solve for the unknown. Let's take a look at another. This is if they're moving away from each other. That's part of our, you know, where the two objects are moving in the same direction or in opposite directions. That was in opposite directions. I'll bet the next one's going to be they're moving in the same direction. Let's take a look at it. Kim drove toward her friend's house at 42 kilometers an hour. I'm just going to start illustrating it so I can get an idea of what's going on. She's driving towards her friend's house at 42 kilometers an hour. So distance is equal to rate times time. This is Kim, and her rate is 42 kilometers an hour. Kim drove towards her friend's house at 42 kilometers an hour. Sometime later, so the times aren't going to be the same, sometime later, Bill left traveling in the same direction, traveling at 70 kilometers an hour. So Bill's going in the same direction. I'm not going to put it right on top there. I'll just draw it down here. But he's right behind her. And he's going 70 kilometers an hour. So this is D equals RT. 70T. I'm going to keep reading and fill in whatever else I can fill in. And this is, what's his name? Bill, D sub B. In the same direction, 70 kilometers an hour. After traveling for 3 hours, Bill caught up with Kim. That gives me the time that Bill was traveling. Bill was traveling for 3 hours. So we know how far Bill went. Distance is equal to rate times time. Bill went 210 miles. Now here's what we're going to do here. We're going to take a look at this and say, how long had Kim traveled when Bill caught up? Alrighty, so I think we've got everything we need plugged into our two formulas here. How long had Kim traveled when Bill caught up? Well, when Bill caught up, the thing is, the way we're thinking about this, he's following right behind her. He's getting closer and closer and closer and closer, and at the moment he catches up to her, however far she's traveled is how far he's traveled. So their distances are the same. So at this point I can say, well, D sub K is equal to D sub B, or this has to be equal to this. And if that's true, then I can solve for time, which is what it was asked for. The time that Kim traveled is my unknown here. And I say, well, these two have to be equal because when Bill catches Kim, they've traveled the same distance. So I will take 42T, set it equal to 70 times 3, which is 210. Got a very simple equation here. I'm going to divide both sides by 4, and T will equal 5, whatever that is. Oh, that's 42T, my bad. I didn't bring it down correctly. T equals 42T, so 42T is equal to, that's this distance. The distance that Bill traveled would be 210. They have to be equal to each other because when he caught up, they traveled the same distance. And we divide both sides by 42. And I believe that will be 5. Let me check that with my calculator real quick. Oh, I got the key right here. Let's see. Yeah, the T is 5. Yay, time is 5, and that would be hours. And that's the kind of thing we do in the same direction problem, often in the same direction problem. They're moving in the same direction and they want to know something about how long after one of them catches the other one. that means their distances are going to be the same. So you can write two variable equations and then say, well, this has to equal this, set them equal to each other, and solve for whatever it is that you don't know. Just wanted to illustrate a couple of types of problems you're going to run into today. Distance is equal to rate times time. You can do this.